Merry Christmas, guys! This video is going to be pretty short, but I just wanted to introduce the third part of the Dirac notation. It's building upon our two elements of the Dirac notation we know already, the bra and the ket, but now it's putting them in the context of quantum states and quantum information like we discussed in the previous video. So as we discussed in the previous video, a quantum state can be represented by the Greek letter psi. Now, if we have a column vector, ket psi, that is represented like this. And let's say it represents an arbitrary combination of ket 0 and ket 1, a qubit, so a combination of two classical states, the 0 and the 1 state. So let's say it's, for example, 2i over 3, ket 0, and then minus 2/3 ket 1. And that's in the same state that we talked about earlier of alpha and beta being these coefficients here. And if you do the square root of the sum of the magnitudes of alpha and beta squared, then you will get 1, because that is the property that we discussed in the last video of any quantum state. So this part of the Dirac notation is basically how we can transform a quantum state from ket to bra, or the row vector to the column vector. So for this particular quantum state, the bra of psi is going to be equal to the conjugate transpose of the column vector. So that means it is 1 minus 2i over 3, and it's not going to be ket 0, it's going to be bra 0, because now we're dealing with row vectors instead of column vectors, and then minus 2/3 of 1. And the transpose in the conjugate transpose definition just means that instead of dealing with kets, we're now dealing with bras, and we are taking the conjugate, the complex conjugate of each of these elements. So in an a plus bi complex number, the conjugate is just going to be a minus bi. So that's what we're doing in this situation. We are flipping it. So for this element, the ket version will be 1/3 plus 2i over 3. We're now doing 1/3 minus 2i over 3. And since this, the ket 1 to the bra 1 is only the real part, we don't have to do anything because there is no imaginary element to the complex number. So yeah, that's the third part to the Dirac notation. Thank you.